Hi, I'm Dr. God King, and today I am going to talk about infinite multiplication table. Our mantra for this presentation, and in particular the infinite multiplication table, is don't memorize, derive. This contrasts the traditional approach towards the normal multiplication table, which nowadays goes from one times table to 12 times table. Our own concept of the multiplication table is that it is not finite, it is infinite. That's why we are referring to it as the infinite multiplication table. So, what's the history of the infinite multiplication table? The multiplication table was invented about 4,000 years ago by the Babylonians in what is present day Iraq. At the time that they invented the multiplication table, it was in base 60. And just over 2,300 years ago, the Chinese innovated on the multiplication table and came up with a multiplication table in base 10. So there have been innovators on the process of how to multiply using the multiplication table, and recently, in the last 2,000 years or so, the Europeans and the Indians have made great contribution. But in the history of innovation of the multiplication table, we don't have Africans. The Europeans came to America and spread their methods, but we do not have Africans making any impact on the multiplication table with regard to innovation. So that is about to change. Africa, and in particular, Sierra Leone, is going to make a great impact on how the multiplication table is learned as well as mastered. So the paradigm that we are introducing is think like a salon mathematician. Mathematician is an interesting concept because it means that you should be producing results just like a magician does. So magicians usually deliver surprise in a way that appears almost impossible. So that's our goal. It's to produce answers to multiplication problems as fast as they are sometimes reproduced. So one thing to note about the approaches of mathematicians is that they do multiplication, they think, they multiply and read numbers from left to right. We normally read numbers from left to right, but when we do traditional multiplication, we do it from right to left. So we shall stick with the tradition or with the innovation of mathematicians who do multiplication from left to right. So what is the process? There are 4 steps. The first step that we are going to use is that rather than a 12 by 12 traditional multiplication table, we are going to use a 10 by 10 multiplication table. So that means that we are getting rid of the 11 times table as well as the 12 times table because they are inherent in a 10 by 10 table. So we get rid of those 2 columns. So in fact, we are dealing with a smaller size multiplication table. The next step is to chunk or divide the 10 by 10 grid or 10 by 10 multiplication table into 4 quadrants. And these are quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So each quadrant, just like this one, has got a 5 by 5 table. So quadrant 2 will have a 5 by 5 quadrant from 6 to 10, and from 1 to 5. Quadrant 3 will have from 6 to 10 here, and 1 to 5, and this will have from 6 to 10 and 6 to 10. So these 4 quadrants will define our multiplication table. And when you are learning things in segments, quadrant by quadrant, then it's a lot easier because you are not dealing with a lot of information at one time. So these 4 quadrants will define the multiplication table. So the third step is to derive the multiplication table quadrant by quadrant and master the multiplication table quadrant by quadrant. So you will begin with quadrant 1 and master it, and then you go to quadrant 2, quadrant 3, and quadrant 4. I would like to point out that quadrant 1 is the green quadrant. So what you see here and what is indicated is this diagonal line. So it means that this multiplication table is symmetrical about the diagonal line. So you in fact don't need to memorize everything. You just need to memorize half of this multiplication table because the other side will be the same. Quadrant 2 hasn't got any symmetry, as is the case with quadrant 3, but in quadrant 4 you have also got symmetry. So you can focus on half of the table and the other half will do the same. When learning traditional multiplication tables, symmetry is not usually pointed out, but it will be good to pay attention to symmetry if you are to learn the multiplication table very fast. So the fourth step is that you should discover and summarize patterns. You should discover and summarize patterns, and there are many ways to summarize patterns, which we shall see in due course. After you have summarized the patterns, it's good at the end when you are practicing a multiplication table. It's good to do what's known as skip counting using your 5 fingers. So, for example, ordinary counting involves 1, 2, 3, 4, 5. But when you are doing skip counting, for example, in 2, it's 2, 4, 6, 8, 10. Skip counting in 3 would be 3, 6, 9, 12, 15. So by associating each finger with a number, you can derive the multiplication table. For example, 3, 6, 9, 12. I know that this is 4, so 4 times 3 is 12. So it's good to do that summary at the end so that you can have a reference for your multiplication table, which is tactile. So having said that, let's look at how we can derive the content of the green quadrant multiplication table. So we use the process which is known as times table addition, and this is one of 3 processes that a salon mathematician uses. The other 2 processes are the hip-hop multiplication and the zigzag multiplication, but for this exercise we are concentrating on the times table addition. What the times table addition means is that you can add columns of multiplication table. For example, 2 times table would be like 1 times table plus 1 times table. This is similar to a 1 times table. So 1 plus 1 gives you 2, 2 plus 2 gives you 4. We are using green since it's a green quadrant. 3 plus 3, 6, 4 plus 4, 8, and 5 plus 5, 10. So the 2 times table gives you 2, 4, 6, 8, 10. And you can summarize this by doing skip counting so that you go through 2, 4, 6, 8, 10. And for the 3 times table, 3 is 1 times table plus 2 times table. So 1 plus 2 is 3, 2 plus 4, 6, 3 plus 6, 9, 4 plus 8, 12, 5 plus 10, 15. And you can skip count in 3, which means that you have 3, 6, 9, 12, 15. So you can summarize the outcomes of a 3 times table. A 4 times table, you can do it either as a 3 times table plus a 1 times table. So 3 plus 1 is 4. 2 plus 6 gives you 8. 3 plus 9 gives you 12. 4 plus 12 gives you 16. And 5 and 15 give you 20. Note that a 4 times table, we could have also said it's 2 times a 2 times table. So 2 times 2 is 4, 2 times 4 is 8, 2 times 6 is 12, and 2 times 8 is 16, and 2 times. So there are many ways of doing these using patterns. And for the 5 times table, we can say, we can use, for example, 2 times table plus 3 times table. So 2 plus 3 is 5, 4 plus 6 is 10, 6 plus 9 is 15, 8 plus 12 is 20, and 10 plus 15 gives you 25. And just to skip count, you can have 5, 10, 15, 20, 25. So you can use this pattern of what I call times table addition to derive the entire 10 by 10 table. In the next part of this series on the infinite multiplication table, we shall talk about how to derive the content for quadrant 2, quadrant 3, and quadrant 4. This is all that I have to present now, and thank you for your attention. This is Dr. God King saying bye-bye. Bye.